Hello everyone, and welcome to our 21st lesson for our COVID journey on logarithms and logarithmic functions for Algebra 2. This is Miss Peltier. Your assignment for this section will be due on May the 15th. So make sure you're keeping up with that. Check your Google Classroom. I'll also have not only the PDF, I'll have a Desmos, and if there's an IXL that goes with this section, I'll have that posted in there too. We're going to be looking at logs. So if you notice our definition for a log with base b, they tell us that we're going to let base b and x be positive numbers. Now remember, positive numbers doesn't just mean that it's not a negative number. A positive number is not zero. Zero's neutral. So it's all those numbers that are not negatives and not zero. And also, in addition to that, b cannot equal 1. So b can be anything but 1. And notice in our two equations we have a b and we have an x. So those are the places where you're looking for these values to be positive numbers and to not be equal to 1. Same thing when it's written as a log. You have a base and you have a number for your x. Okay. It goes on to tell us about how it's written and how things can be written. We talked earlier about how logs are simply inverses of exponentials. Now, I use a little trick to help you to remember how to turn an exponent into a log and vice versa, a log back into an exponential. If you have an exponential and you want to convert it to the log, I'm always going to start with my base. So my base is the important part that I want to start with. And it's going to be, this would convert to log base b. Notice that's what I start with, log base b of this number. That's how we read this, log base b of y is equal to the exponent. And notice if you start with your base, it sort of makes a circle around. You go from the base to what it's equal to and then back around to the exponent. And that's even if it's flipped around. Always start with your base. The same thing works if you're looking at your log. If you start with the base, you're going to say the base raised to this exponent would be equal to whatever's right here after your log of. Okay, so see how it also makes a nice little circle. So I have a few examples to show you to give you a little bit of practice before you start working on your assignment. Super easy stuff. We have logarithms. We want to convert them to our exponential form. So we always want to start with that base. Here, my base is 3. I'm going to start with 3. I'm going to raise it to what it's equal to, the 5, equals whatever number's here, 243. And if you plug that into your calculator, 3 to the 5th, you should get 243. But on these, all we're doing is practicing writing, so you don't have to check them all. But the main thing is that you're writing it in the right order and that you know where everything goes. Okay, so with number 2, we're going to start with our base of 3. It will be raised to this power, -4, equals this stuff, 1 over 81. Same thing here, even though we have decimals, not a problem. Base of 10 raised to this power, -5, is equal to all of this stuff, 0.1, 2, 3, 4, 4 zeros and a 1. Same thing here, start with my base, 25. It will be raised to this power, 1/2, is equal to this stuff, 5. And every single time, if you use the little circle, it'll help you write your exponential form. Now, we also can go from exponential form to logarithmic form. Again, we're going to do the same thing. Since we want to go to logarithmic form, we're going to start with log, and then we always start with our base. Here, our base is 6. So you're looking for the number that has the exponent on it. That's your base. Our base is always a subscript, and it's written below. So it's a little bit smaller and a little bit below. Kind of like an exponent, but on the other side. So log base 6 of whatever it's equal to, the 1 over 216, is equal to the exponent, -3. So there's your log form. If you want to write this in log form, you would start with log and your base of 7. Always look for that base. Base of 1, log base 7 of 1 is equal to the exponent 0. For this one, log, our base is a fraction. That's okay. It's a positive number. It can still be a fraction. That's all right. Log base 1/4 of 1 over 64 is equal to the exponent of 3. And lastly, for this kind, start with our base of 3. Log base 3 of 1 over 81 is equal to our -4. Okay? All right. Now, we also have some problems where they're going to ask us to evaluate. Remember, evaluate basically means find the number. Find what this is equal to. So, for me, what I like to do is I like to just add on to that equals x, because that's what I'm looking for. That's the value I don't know. They didn't give it to me as an equation, but if I know it's going to be equal to that, then I can go find it. So for me, visually, that helps me because I get the little circle thing and I can make it an exponent. So I could say 8 raised to the power of x is equal to 16. And we did these problems the other day. Remember, we want to make our bases the same. So 8, I could write 8 as 2 to the 3rd. And since that is raised to the power of x, I would multiply my exponents together. So 2 to the 3x. And then my 16 would be 2 to the 4th power. And we know if our bases are the same, then our exponents must be the same as well. So we can write our equation 3x is equal to 4, and when we divide by 4, we get x is equal to 4/3. We double check, that could be a 4/3, that's a good answer. So you can write it as x equal 4/3. The answer is really just 4/3 because they're just wanting to know what that is equivalent to. Okay? Same thing here, I would make this equal to x, start with my base of 3, raised to what power is equal to 81? Well, I can make my bases the same because I know that 81 is 3 to the 4th power. Because 3 times 3 is 9, times 3 is 27, times 3 would give me 81. That's where I get my 4. Once these are equal, then I know my exponents are equal, so it must be x. Sorry, it must be 4. So I know that the log base 3 of 81 is equal to 4. Even if it's a fraction, I can still do the same thing. 2 raised to what power is going to give me 1 over 16. But remember, when I have a fraction and I want to make this a base of 2, to move this up into the top, we have to make that a negative exponent. So I know 16 is 2 to the 4th, so that's going to be a -4. So 2 to the x is equal to 2 to the -4. Bases are the same, so I know my exponents are the same. And lastly, if I set this equal to x, base of 9 raised to this power is equal to 1. Now this is one of those we just have to remember our rules, things that we know about exponents. I know anything and everything is equal to 1 if my exponent is what? Yes, if my exponent is a 0. Anything raised to the 0 power is 1. And we talked about that when we did our graphing, remember? So we know that that would be equal to 0. So we could say the log base 9 of 1 is equal to 0. And anytime you see a log with any base of 1, it's always going to be equal to 0. Okay? All right, so that was a quick short lesson for you. So hopefully you are able to do your assignment. Your problems on this one, your worksheet, you'll get to choose. We put several problems on the worksheet, but you'll be able to do a choose two, or whatever, so that you have a few and you don't have to do all 16, unless you just so choose that that's what you want to do. We did 12 problems really quickly in about 10 minutes, so you could certainly do all 16 if you so choose, but 10's really all you need to do. Okay, so y'all have a good day, stay safe, and we will see you on the next video. Have a good day. Bye-bye.